Everyone, and welcome to my YouTube channel. Can you solve this interesting infinite nested radicals? And what is I? I is the complex number. So basically I is a square root of minus 1. How can we solve this problem? So let's start with what we have here first, the simplest one. If I have just the ith root of I, and by the way, we know from the complex number theory that I can be written as e to the power of I pi over 2. So I'm going to make use of this a lot. So this will be I to the power of 1 over I. And this is basically e to the power of I pi over 2 to the power of 1 over I. So I will be cancelled. And this is nothing but e to the power of pi over 2. Okay, fair enough. And then I have the ith root of this guy here, which is basically e to the power of pi over 2 to the power of 1 over I. But 1 over I, by the way, guys, it can be written as minus I. We can make use of that as well. So basically, this will be e to the power of minus I pi over 2. And then I have another one. Let's go for another one. So square root of I, square root of I, square root of, sorry, not the square root, but rather the ith root. That's wrong to say. So basically, this will be e to the power of minus I pi over 2 to the power of 1 over I. And this is nothing but e to the power of minus pi over 2. So you can already see that actually it is following a pattern. So we just go forward until we find the pattern. So from this, we had this, and then from this, we had this. I can imagine what the next one will be, but let's see. So let's take this a because I don't want to write all of these nested radicals. So then I have I basically a, it will be e to the power of minus pi over 2 to the power of 1 over I. By the way, 1 over I is basically minus I, and this is nothing but e to the power of I pi over 2, as I guessed. If I just, let's call this b. So if I proceed one more time, so the ith root of b will be e to the power of I pi over 2 to the power of 1 over I, and that is nothing but e to the power of pi over 2, which we initially had here. So in other words, by the way, I here has been repeated 5 times, and here it has been repeated 4 times, and here it has been repeated 3 times, as you can see. So the general formula for that nested radical, so basically I all the way to, yeah, I, the ith root of, I, this will be e to the power of pi over 2 if basically we have just one, let's call it for k plus 1, and k belongs to, natural, let's say, k starts from 0 and 1 to, and all the way to infinity, and then we have after that e to the power of minus I pi over 2, okay, and that is nothing but only for k plus 2, and then we have e to the power of, after that, minus pi over 2, okay, and that is for basically 4k plus 3's, and then we have e to the power of I pi over 2 for 4k plus 4, and then after that it will repeat itself. So if k goes to infinity, or this infinite radicals, it will never converge. So this is basically a diverging series, and all the values on the complex plane, depending on what k is. So if this is the complex plane, so here is y and this is x. So one's actually, let's say this is minus 1, and this is I, this is 1, this is minus I. And if you look at these values, e to the power of minus I pi over 2 basically is minus I, and this guy is also I. So basically e to the power of p over 2 is somewhere here. Let's say this is e to the power of pi over 2. It's definitely beyond the unit circle, and then from that we jump to minus I here, and then from that we jump to e to the power of minus pi over 2, which must be somewhere here. It's a small positive number, definitely less than 1, and then we have e to the power of I pi over 2, which is basically I, and then we come here. So it's just alternating between these four values, and it definitely diverges. I hope that you enjoyed this very short video. It was cool, and I wanted to share my solution with you guys. So this is a diverging series. See you next time for the next problem.